is how we install the vibrosensor on a cylindrical end winding. And then another key component we will cover is the hermetic junction plate. The hermetic junction plate is critical in a high generator because inside the generator you got 70 kpsi of hydrogen, and hydrogen can be an explosive environment if there should be any leak. So what you would like to do is to minimize the number of holes you have to drill into your generator wall, because the smaller the hole, the larger number of holes, the higher will be the probability of getting a leak. So with that concept, we make a large junction plate, and more will be described about that. And then we will, before we close, we will talk about the feature and benefit of TG Guard, and then the extra values that we provide. We are actually not into just making a transaction. We want to build relationship with our client, and we are interested in this SEW problem. I think in the industry there is still some controversy, and for example, some engineer will say, well, the vibration in the generator is mechanical in nature. It starts by having imbalance, and the whole frame of the stator is vibrating. Okay, and now if we think about that concept, then the vibration frequency of such signal should be one-time line frequency, because if the stator, the whole stator is rocking, and it should be aligned with the rotation rate of the rotor. But anyway, I am very interested in participating in this discussion, and today, if you have some question you want to ask me, please go to that chat box and write down your question, and I will be able to answer them at the end of the main webinar, where we have a question and answer period. First, this is a Perky plant in Marshall, Texas, and it is a coal-fired power plant with scrubber. So rest assured that this will run for a long time, because I know a lot of people are concerned about greenhouse gas, and then regulation is beginning to happen to force utility company to retire some of the smaller coal-fired plant. This plant is owned by AEP. Shown here is our field engineer standing in front of an open generator. By the way, the generator is quite large. It's 775 kVA and made by Westinghouse, and it's about 32, 33 years old. The first thing we do before any installation, which is critical, is to confirm that none of the end winding is having a resonant frequency at 120 Hertz. Because if they do, then you will have tremendous problem. So at resonance, the amplitude could increase to 100 times, and that will for sure cause you problem in the operation of the generator. So we did that. And the other problem I mentioned to you before about how to deal with a round shape end winding, and here it is. Remember that our vibration sensor comes in a thin rectangular slab. By the way, the color is black because the coal-fired generator is expected to run at higher temperature than a small hydropower plant. Remember the last time I showed a fiber sensor is white, and this is now black because it's made with polycarbonate. It is a high temperature material. So you take Dacron, which is a fiberglass type of cloth, soft cloth, and fold it into several layers, and then soak the whole thing in resin. So now the whole assembly become like a dough that is shapeable. And you take this assembly and you put it on the end winding. Since the surfaces are soft, so one side will conform to the curve of the end winding, the other side will conform to the flat surface of the fibrofiber sensor. The only thing is you have to plan ahead, and you need to have many clamps available to hold this in place. This is because the resin will need some time to cure, and it's 8 hours. Now, with this provision, we probably will take one more day in installing all the 12 sensors, making it 2 days. With the simple non-resin base, like the hydro generator in India, the installation work can be completed in 1 day. So once it's cured, the whole thing becomes one block. And just to be safe, the customer wants us to wrap around the sensor put together with the cable so securely, and so that nothing will ever fly around, and this can be quite dangerous. And you notice that all the sensors are now installed the same way. There are 6 on each end. You see the cables running. And then on the other end, we put 7. Okay. At the customer request, one of the sensors was actually installed directly on the copper conductor, because our sensor is non-conducting, so this is perfectly safe. When everything is done, you notice that the sensor and the locations are all covered by the same red paint, and you can hardly see anything. Okay, so this is quite seamless. We make sure we do not disturb anything inside the generator. So we're now ready to talk about another critical part. The critical part is the junction plate. The hermetic junction plate, as you see, is actually a cylindrical device filled by a dense epoxy. This is high temperature epoxy. And looking at the cross section of this, you see that the fiber cables are all buried inside the epoxy. And by the way, this junction plate has been custom made for us by our partner who has been serving the space and semiconductor industry, and has been leak test to 10 to the -7. And by calculation, it will take hydrogen gas 100 years to leak out from the inside of the generator to the outside. Now, beyond that, having this hermetic junction plate, it will only require you to open up 2 holes. And there are standard parts that you can buy that you can weld onto the body, on the wall or the cover of the generator. So the part number is listed here, so it's standardized. And then it fits the hermetic junction plate precisely because of the thread mechanism. So silicon gel can be placed, so make also the threaded connection completely hermetic. This slide shows the interconnection of the composite cable, and you notice each fiber has a different color, and this is helping in traceability. When you connect certain sensor, you like to remember which sensor is going to which end winding, isn't it? So we give you that possibility. Another important thing to do is to protect the hermetic junction plates. And shown here, we have added a small metal box and then the little plastic bag to protect the fiber optic connectors. And eventually, everything is fitted inside. And I would like to point out that each connector, after it's made, we put heat string around it so that nobody can ever detach it. This is to make sure the whole setup is reliable, and you can see the hermetic junction plate with the blue color high density epoxy. Now, it is a little bit more work to install the hermetic junction plate, all because we were very conservative and we put long fiber lead length on both sides. And what happened is that when you turn the hermetic junction plate into the hole, into the welded plate, two people have to hold loose cable on one side and then the actual device on the other. Our field engineer is actually working inside the generator, following the motion so that we don't twist the fiber. By the way, this is another sensitive feature of our technology. It's not electrical. In electrical wire, you don't mind twisting it or turning it or folding it into a right angle. I'm afraid you can't do that. Remember, fiberglass is still glass, and the way it guided light, it requires that minimum curvature of 30 millimeter be placed, so you can't make very sharp turns. Okay, now we are on to the system part. The reason why I talk about the system part because it is part of the installation procedure.